So welcome to Everyday Mathematics. Today we continue on this journey of ours of solving the MIT Integration B problems, qualifying exams from the 2011 series. We'll be looking at problems 16, 17, 18, 19, and 20. Where problem 16 is indemnity integral of 1 over natural logarithm of x plus the natural logarithm of natural logarithm of x. And problem 17, another indefinite integral of 1 over 2 plus e to the power x. Problem 18, again an indefinite integral of the square root of x over 1 minus x cubed. Problem 19, an indefinite integral of 4x over 1 minus x to the power 4. And problem 20, which is the indefinite integral of x to the power x times 1 plus the natural logarithm of x. So this is what we'll be doing today. I hope you have some fun following along. So yeah, let's quickly jump and dive into the solutions. 16, which is the indefinite integral of 1 over natural logarithm of x plus the natural logarithm of the natural logarithm of x. This is an interesting problem. My quickest instinct would be to say let u be equal to the natural logarithm of x such that the derivative of natural logarithm of x with respect to x will be 1 over x, and so we would want to substitute for dx over x with du. What happens here as well is that we can say e to the power u is equals to x. That's the same expression. Now, our expression here, 1 over natural logarithm of x plus the natural logarithm of the natural logarithm of x. We could express it as x over natural logarithm of x plus x natural logarithm of x dx, so that these x's cancel out. Now this means that we go back here and borrow e to the power u over u from up here plus e to the power u log, here we're going to put u, and this here happens to be du. Okay, so we've come up with our equation where we have e to the power u over u plus e to the power u log u du. So this part here is a hidden one here, is the same as the derivative of natural logarithm of u. And then since the derivative of e to the power u is e to the power u, we can also say that's the derivative of e to the power u. Okay, now here we're going to use integration by parts in a way that is not commonly used. If we have the derivative of two function u and v, that's the same as u times the derivative of v plus v times the derivative of u with respect to x, so that when you integrate that, this just becomes uv. Now here we could see that our capital U is the same as e to the power u, and our v here is the same as that, and then we see the v here is the same as that, and then our u is the same as e to the power u. And so what that means that our integral here is just going to be and this is a by the way, so we just want to enclose it in the box. But since we've already seen that the integral of this formalism, this part here on our right, is the same as what we have here, this means that our answer is just going to be e to the power u log u plus the integration constant. Now e to the power u is, we said that was x, and u is the same as natural logarithm of x plus c. So this is the answer that we were looking for. So that's number 16. Let's proceed to number 17. Problem 17, which is the indemnity integral of 1 over 2 plus e to the power x. So what I can do here is I can say, okay, I would like to divide the numerator and the denominator by e to the power x. So this is the same as e to the power negative x over 2 e to the power negative x plus 1. And so the numerator e to the power x is the same as half the derivative, and that is obviously negative here, of 2e to the power negative x plus 1. Such that we can express this as negative a half the derivative of 2e to the power negative x over 1 over 2e to the power negative x plus 1. Right? So we say that our problem is a half derivative of 2e to the power negative x plus 1 over 2e to the power negative x plus 1. And we know for any integral, right, I'll draw a rectangle, sorry. If the derivative of a function over the same function, when you integrate that, that's the same as the natural logarithm of that function plus integration constant. So what we have here is the same as the natural logarithm of 2e negative x plus 1 plus c. So that is the answer for problem 17. On to problem 18, which is indemnity integral of square root of x over 1 minus x cubed. So, I mean, the interesting thing here, we can say x to the power a half, which is the same as square root of x, is the same as the square root of 1 minus x cubed. And this is the same as x to the power a half over a square root of 1 minus x to the power 3 over 2, 1 plus x over 3 over 2. Right? And so if I say let u be equal to x to the power 3 over 2, that means that the derivative of x to the power 3 over 2 is same as 3 over 2 x to the power a half, which means that 2 over 3 du is equals to x to the power a half times dx. And this is important for us here, so that we can say that x to the power a half over square root of 1 minus x to the power 3 over 2, 1 plus x to the power 3 over 2 dx same as 2 over 3 du, this part here, is being substituted with 2 over 3 du over the square root of 1 minus u, 1 plus u, which we can just simplify and say this is same as square root of the square root, the integral of the square of 1 over square root of 1 minus u squared times 2 over 3. Now, since our integral is now simplified to this point, we could just say that will be equal to sine theta, and so du d theta is equals to cos theta, so du is equals to cos theta d theta, such that 2 over 3 du over square root of 1 minus u squared is equals to 2 over 3 cos theta over 1 minus sine squared theta. This is this, which is equal to 2 over 3 integral of cos theta over cos theta. Okay, so which is equals to 2 over 3 integral of 1, which is 2 over 3 theta plus c. Since we said u is equals to sine theta, that means that we have 3 over arc sine of u plus c. And since we said that u is equals to x over 3 over 2, to the power 3 over 2, then our integral is the same as arc sine of x to the power 3 over 2 over 2. Okay, so just to express it in a nice, succinct way, the integral of square root of x over 1 minus x cubed dx is the same as 2 over 3 arc sine of x to the power 3 over 2 plus. So, okay, so that covers problem 18. Let's continue to problem 19. So problem 19, which is named integral of 4x over 1 minus x to the power 4. We can always express this as 4x over 1 minus x squared, 1 plus x squared. And so if we say let u be equal to x squared, that means that du dx is the same as 2x, such that du can be used to substitute 2x dx. Very important part here. So that our integral 4x over 1 minus x squared, 1 plus x squared is the same as 2x dx over 1 minus x squared is the same as 2. In place of 2x, in place of this we have du, and then we have 1 minus u, 1 plus u. So this is the same as twice du 1 minus u squared. Okay, this is important, but I think let's just keep it in this way. It's important. Our problem has come to this stage, and so 1 over 1 minus u times 1 plus u is the same as a partial fraction here, such that when you multiply across by 1 over u, when you multiply across by 1 minus u, it becomes 1 over 1 plus u is equals to a plus b 1 minus u 1 plus u, such that when u equals to 1, you have 1 over 2 is equals to a. Similarly, when you multiply across by 1 plus u, you get 1 minus u is equals to a 1 plus u over 1 minus u plus b. And so when u is equals to -1, we have -1 over 2 is equals to b. Okay, so in essence, 1 over 1 minus u 1 plus u is equals to a half 1 minus u minus 1 plus u, so that the integral du over 1 minus u times 1 plus u is equal to a half times 2 the integral of 1 minus u minus 1 plus u, which is equals to half negative natural logarithm of 1 minus u minus natural logarithm of 1 plus u plus c. Since u was 1 minus was the same as x to the power 2, we get negative 1 minus x, natural logarithm of 1 minus x squared minus natural log of 1 plus x squared plus c. And this becomes 1 minus x squared 1 plus x squared plus c is equals to negative 1 minus x to the power 4 plus the integration constant. Okay, so that is our answer for problem 19. It's a very interesting problem. Independent integral of x to the power x times 1 plus natural logarithm of x. So personally what I would do is I would want to substitute for the complicated part. I would say let u be equal to x to the power x, such that natural logarithm of u is equals to x natural logarithm of x, so that when I differentiate with respect to x, we have 1 over u du dx is equals to product. We differentiate first of all with that, so we have natural logarithm of x, because there's a hidden one here, plus x times derivative of 1 over of natural logarithm of x is 1 over x, that cancel, so we have 1 plus natural logarithm of x. Now we have this u, so that we have du is equals to u 1 plus natural logarithm of x dx. This u is x to the power x, so we have x to the power x 1 plus natural logarithm of x dx. So this part here is this entire part here, and so what we can say for now, the integral of x to the power x 1 plus natural logarithm of x dx is the same as the integral of 1, which is u plus the integration constant, and we know u to be x to the power x, so this is our answer. Okay, so that kind of sums up the 5 problems that we needed to look at today. Until next time, be blessed. Bye bye.